right.
All right. Good to go? Great. Hello, everybody. Thank you for joining us at this session. We're going to look into how we pair GenAI with a modern enterprise. It's great for all of us from different parts of Europe or maybe around the world to join this conference. We talk about new things, interesting things, we explore things, what's coming up. But come next Monday, we're going to be back at work, and let's say we're building enterprise software. So what we want to discuss today in the modern enterprise is that generative AI adoption starts from business needs and not from technological aspects. So in today's world, we need to understand our business requirements in a lot more depth than we needed to do that in the past. Companies are always looking for an advantage through new technologies, but that starts from a deep understanding of our business requirements. And this is what would help us adopt new technologies and build different functionality in innovative ways. We want to lead you on a journey, and it takes four steps. First, we always have to start from the problem we're trying to solve, the pain points we have, and what issues do we need to resolve where the business needs to adopt maybe new technology. When we look into, once we have this deep understanding of our business needs, we want to match and pair up features which GenAI brings with what the enterprise would need, where it would help our business. As we move into the solution part, and sure, we want to use Java with GenAI, not because we're here and it's a JVM language-focused conference, but it's because Java is the dominant language of the enterprise. We want to see what technology stack we should pick. How do we build and test and deploy apps in the enterprise? And the last step is we need to get our applications in production. And we're focusing on another set of aspects, like reliability, robustness, and scalability, and security. I'm Dan Dobrin. I'm part of the North American technology team in Google Cloud. I focus on app modernization, the app experience. My background comes from the app world. I build microservice frameworks. I work with customers primarily around serverless, event-driven architectures, GenAI, optimization, and a lot of it in the Java space. I like to speak from time to time at conferences and publish open source, which I hope is helpful for every other developer.
I'm Abdel Segiwar. I'm a developer advocate in the European team based out of Stockholm. I mostly work on Kubernetes-related topics, so I'll be covering the Kubernetes part of the session.
So what is on the agenda today? We want to break it into two parts. First is, we're always going to ask the question, why? Like, why should we adopt GenAI in the modern enterprise? What drives its adoption? And we want to walk not through simple samples. We want to start from a production use case. Looks at its architecture, implementation decisions, the code we had to build, the choices we made for the technology stack. And then in the second part, we want to go into advanced topics and dive into a number of things like best practices and AI patterns, things which we would need in a day-to-day enterprise application. We want to see how we run our app in a serverless environment. What do we need to do around optimization? Because optimization is not a day two concern. It's something we have to think about from the beginning. Data is at the core of our business, but in the GenAI space, we're dealing with enterprise data, we're dealing with large language models. So we want to see, where are they deployed? How do we observe the interaction with them? What choices should we make? And then we'll end up with maybe fun things which we as developers might or not be exposed. Scripting. So if we started in the past from a cloud application in production, we had a number of subsystems. Around like the compute part, But every enterprise app has some database, some messaging, some data of some sort. And in production, we always care about observability, so logging and monitoring. So how about a GenAI cloud app in production? We add additional technologies and additional dimensions to it. What we want to focus today on is 4 areas: how we build and deploy our app, data, how we interact with large language models, and what they bring to our applications, and how do we observe them. So as an application in the past, we started with something like we had a database, we looked at the application, we could find some, let's say this gets you quotes from famous authors, we could get random quotes. That's what we did in the past. But now we have multiple choices. We can use large language models to do that, and also large language models which run in various areas. How do we learn? To quote our esteemed colleague Venkat, he has a session, I think, at the same time with us. He was mentioning that learning should aid and focus on knowledge application instead of knowledge acquisition. We want to try things out. We don't just want to learn some concept. So we want to arm you at the end of our session with 2 code bases. One is for the app which we run in the cloud, and this app brings features which we're familiar with, but also new GenAI specific features, and those we extracted and put separately in a code lab so that you can also try them out separately and see what you're going to learn throughout this session. Now let's focus on a production use case. While we cannot talk about our customer work, this is inspired by the work we did with some of our customers, and it takes this fictitious university which operates an internal book review site, and students and faculty would submit reviews for public or university internal books, documents, research paper, and the university wants to bring it up to, let's say, the current day and age. Why pick a university? It's actually some of the use cases I validated with my own children who studied in this university, and they were saying, wow, our application, our university still works only with some technology since you were young. So what is the current architecture of this application? It's a low scalability application deployed on-prem. It's a Java app server. It's always hard to maintain and secure it because it's built on an older Java stack, and there are many times CVs are encountered. There are outages during deployment. There's a challenging development environment because adding new features requested by the user base are either difficult or quite hard to implement in the current stack. And there's also cost. Sometimes you over-provision by too much hardware, and maintenance and costs are increasing significantly. So what is the ask for this modernization? Well, we want a modern stack. Build it. The university is looking at building and deploying the app, following modern best practices on a flexible architecture so that they can easily expand and add new business features. Scalability and cost is obviously important, and as the usage is different. In universities, maybe around exam season or reading week, there's a lot more usage than maybe on other times. But there are also new features requested, like how can you summarize or classify or review different documents on demand? How can you ingest lots of documents in different formats, which could not be just text, could be audio or video files, or issue recommendations. So these features drive and make us interested in how do we solve them, because we can't solve them easily or cannot solve them at all with the technology we had before. So let's double click a bit into these new features. What are the requests here? So we have to follow these business requirements, and then we want to implement them and see how we can bring them into the new application. So one would be multi-modal ingestion and consumption of public and internal materials. students or faculty can add documents, but they could also be added offline in batches, overnight or at other times of the day. There's a demand for being able to have automatic book reviews or summarization, whether on demand, when you ingest documents in the background, or from different ways of like a web app or mobile app. Then as you're looking through materials, if they are available in the bookstore and you want right away information about its up-to-date availability and pricing and the format of those materials in the bookstore. Then you want to do a book analysis by keyword refined by users, but also classify books and do sentiment analysis with similar book recommendations. My daughter really wanted to have a feature like that in her bookstore. So we might or we might not be as familiar with GenAI technology, so just let's take a couple of minutes to just review some of the GenAI concepts. So LLMs are like machine learning models. They're trained on vast amounts of data, and they can comprehend and generate human language text. We interact with them with prompts. Prompts will direct how the model responds to us. This is how we interact with it, and prompt engineering becomes critical for our model output. We want to use templates as the prompts we use. We want to be able to reuse them over and over again. Embeddings represent meaning. So there's a numeric representation of text, which is into a text to be formatted, in a format to be processed by LLMs, and it captures text semantics. These embeddings are stored in vector databases. We store them and we manage them in vector databases with the goal of finding relevant text based on semantic similarity. Now, LLMs are stateless. So we want to use memory and state for context retention over multiple interactions. For us as developers, how do we interact with LLMs? APIs are published by the different LLM providers, but for us as developers, we don't want to write our application in the enterprise against APIs, so we would like to have SDKs, which we could easily use in an IDE and program against them. Can we make it even simpler? Yes, but as a basic step, we would like to program against SDKs. Now, function calling is one aspect which is very important to us. Models are trained, but they have a cutoff date. One day, this is let's say it was, May 1st, the model has, this is when the model has been trained, it's the end day. But it does not know about information, what happened afterwards. So, plus, it might also not know, and it should not know, about any private information, let's say user information or availability of a book in a bookstore. So we want to use function calling to help fill these gaps and provide up-to-date relevant information for our LLM applications. Now, when we build our applications, we always start from a foundation model. And sometimes they could be public models. They could be proprietary models. There's a myriad of different models available to us specialized in different areas. But those have a general knowledge. Even the ones built for specific knowledge don't have maybe the information which we would like to do. So optionally, we could fine-tune these models and use them. But fine-tuning requires us to update this fine-tuning all the time, because every fine-tune has, again, a cutoff date. So we want to add here vectors and data which we want to contribute, enterprise data, which we want to contribute to the overall response. So retrieval augmented generation would be the process of optimizing the output of the LLM by adding the supplementary knowledge in addition to the training data before we generate a response. Now, conceptually, let's walk over 4 use cases. And for each one, we want to see what type of GenAI concept we bring to the table. One would be, in the business requirements, we were asked to be able to ingest documents in various forms. So we want to upload data, and we put a generic job control. Don't consider it as a one-time job, but this is one orchestration class which would drive this particular use case. So we want to load the document, format it, split the text, and then conceptually, we're not talking about tooling and how this gets implemented. Conceptually, we need an embedding model where we create embeddings and then we store them in a vector database. On the implementation side, we have different choices, but let's start with this. We can now decide whether we want to summarize the text automatically. Each time we ingest a document, let's provide a summary, or we don't. That is a decision, and we should build in flexibility because we were asked to provide also on-demand flexibility. Now, when we look at these features, what did we bring new? We're going to use as a model for this application Gemini as one of the Google models. So what features do we need here? We need to chat with a model. We need to deal with embeddings. We need different prompts, and we want to use templates here. We need some document utilities which would help us split documents, and we don't want to split them arbitrarily. We want to split them by paragraphs, by sentences, by words. And we might or might not want to implement here summarization as a pattern. When we consume an image, many times we see a book. We see a book on somebody's desk, or we see it somewhere lying around in a classroom, and we want to take a picture. So out of this book, we want to, when we see this book, the simplest use case would be, tell me more about this book. But tell me more would be who wrote it, what the title is, what a summary of the book would be, just to have an idea of it, but also where I could find it. I don't want to do and get another search. So we can upload an image, extract the text from the image, and here we use, you can see in the LLM inference stack, we use multiple services also. That does not have to be in the implementation, different ones. We extract the text from the image, query for the book summary in the database. It might be there, it might be added manually, it might be added automatically. Then we prompt the LLM with this information, and we're asking, well, also tell us where is this book available, in which format. So the LLM will decide on functions which we pre-register. It will determine whether to call a function or whether it will not. So if it calls a function, these are functions which we build, could be existing microservices in the university, or it could be new services which we're by now used to. Here's a Spring Boot service which will call my function. And in the end, armed with all this information, the image information, summaries, information from the function, we can prompt the LLM for a response. So let's see how if we run this. What do we want to do? First, we don't have this book, and we want to run a book. Now the time spent is here, and we're going to analyze each one. It's the time to spend to start our Java application. This is built with Java 21, and also the time required to perform embeddings, to find our information, and to invoke the LLMs. So the upload of the file has been successful. So where do we find the file? If we look into our books, we're going to find the file. We uploaded the Jungle Book. I think it's a book which all of us are familiar with. We see the book, and we want to see that the service has processed it. We're going to come back to the implementation, but here we just want to see it in action. And we can see that it split up the document. If I make it smaller, I don't know if you see it, but can you see this still? Yeah. So if we look at it, a file has been uploaded. This is where it ended up in a storage. We found this book, It's split into a number of chunks. Embedding status is completed, and the information has been stored. If we look into the database, we can see that now the data has been added, the pages of the documents have been added, and if we look, we see the actual file content and we see the embeddings. That's great. Now let's see if we have to consume the image. I'm going to take the picture of the Jungle Book as well. We used here books and images from the Gutenberg project. There's no issue with licensing, so that's why we can use them freely. So we uploaded this file. What do we want to observe? We want to observe that our file is now available. It has been uploaded. We want to see that it is being processed. And in the end, we want to write a result into a NoSQL database for further communication. So we can see we ran this image. We picked up the summary of the book. We called the function. It tells us that the book is available in the university bookstore. It will perform all the safety checks. It will check if there's PI data to be managed, and in the end, it will write the output in a NoSQL database. Internet could be a bit faster, but it is here. And what do we want to store? The final model response, and we want to have the title and captured of the book. Now, this could be on the ingestion side and also on the consumption side, the inference. So what features did we need here? We needed to chat with the model. We needed structured output. When we want title, and it's very clear information, we want title and books and so on, we want that all returned in a nice structure in a JSON format. We use again prompt and embeddings. We use retrieval augmented generation and thus function calling, because we are getting up-to-date information from our existing services, and by this we can complete the use case. But there are also other use cases which are interesting for us. Some are for analyzing a number of books. Many times we want to see, especially during exam season, well, will this book, should I get a quick synopsis of the book? How will a number of keywords play into a book, let's say friendship or adventure, into something like the Jungle Book? And we need, again, our databases. And we could have theoretically a simpler use case. But at the same time, we have also use cases where we want to summarize a book on demand. Or if the information is not available in the bookstore, we want the search to be grounded with web search. So the LLM, we want to empower the LLM to do Google web search to retrieve that information for us. If that is not available to us, we should be able to do it. So let's see how this runs. We do not have this book. We do not have this book. It's written by a Mexican writer, and we do not have this book. We do not have this summary. But we want to be able to run it, and if the LLM does not have the information, we want to delegate for it to go and retrieve that information for us, so it can do that on our behalf. On the other hand, if we want to summarize this book, we didn't do the summary in the ingestion on purpose, so that we can show how we can run this also separately. We can see the time spent. This is not the application. This is taking an entire book, and it will provide a summary. And it took whatever it took, almost or so on 20 seconds. So when we look at our use cases, each one of these use cases capture what our business requirements need. So we can see that we can add some features, and they allow us to ingest on demand, summarize, get up-to-date information, all the features which the university wants to add in the application. So conceptually, we think we have analyzed it properly. We think we have identified the features which we want to build, and we want to be able now to implement it. And now as we walk through the use cases, so now let's think about how we architected this before we go into the code. So as a high-level architecture, we have two systems. We have two subsystems. One is the data ingestion subsystem, where we would upload maybe documents or images or so on in bulk. And we have a serving subsystem where users would interact with that information. How do we get the information, and where do we store it, and how do we process it? So when we upload documents, you saw we upload them to a cloud storage bucket. Each time an object is created, a notification is emitted, and we can capture it with EventArc, which will send it. EventArc is backed by a messaging system, PubSub. EventArc is a tool which would allow you to bridge anything with everything, any source of an event with a destination in compute. And we want to run this service in a serverless environment. We were asked to be mindful of costs, so by the university requirements, so we want to use a pay-per-use model. Where does the information get stored? We store both embeddings as well as the internal data in a Postgres database. But it is not any Postgres database. It is a Postgres database which has Postgres vector enabled capabilities, which allows us to store the enterprise data as well as the internal, as well as the embeddings in one single database. Now there are multiple implementations of Postgres in the cloud. One would be AlloyDB, and AlloyDB is a clean implementation of Postgres, implemented from scratch by Google. It is a fast database, which is X times faster than a regular Postgres implementation. We have to make here an opinionated decision on our architecture. And later when we take best practice in every single part, we look at it with a magnifying glass, we're going to discuss different choices. But when we look at the entire architecture, we need to make an opinionated decision. We're going to use in VertexAI, which is the service by which you can provide models for consumption to users. We're going to use Gemini models, and here we're using the latest Gemini Pro. On the consumption side, whatever your front end would be an app, could be a mobile. We're going to use Cloud Run as well. And you can upload as well images, and that would trigger, get a notification and the execution. So you could see we upload an image, or we could interact directly with it. So two things which we want to look into, and then look into the code for them, because it's important for us to understand. This architecture is maps to the Google reference architecture for serverless environments for GenAI applications, and there's a QR code for it. By the way, we put QR code for all our samples and all our code bases, so that and for whoever is watching the recording, you can easily capture a QR code for every single link. Now, in the technology stack, we picked this AlloyDB AI because for a developer, it is a familiar interface to work with. But now it's familiar for us to work across data, vectors, and models, and we're going to see how simple it is for us as developers. Now, AlloyDB is optimized for GenAI apps with both real-time and high accuracy in mind. The management is simpler. Instead of us managing multiple databases, you saw conceptually we illustrated a vector database and our enterprise database. But If we have it in one single database, it's simplified database management and for database administrators. One administrator can handle both, and the upskilling effort is much lower. Scalability and availability and security are built like at enterprise level and at the scale offered by Google Managed Services. Now, we deployed to Cloud Run because we had that requirement of building fast scaling and scale to zero and pay-per-use applications. Cloud Run would allow you to deploy your containerized applications and will take your Java GenAI applications to a serverless environment. Now, these containers, what is important for us to know is that when we build these containers, these are portable, OCI-compliant containers, which if we choose to deploy them later on Kubernetes, we can easily do so. Once the application is containerized, we can make any choice we want to make. So let's look a bit of why is Alloy interesting for us? And let's look a bit at the code. If we look at the DDL for this database, we have an authors table. This is fine. But if you see, for a developer does not know when inserting data that they are working with a vector database as well. So in the DDL, we can specify the embedding as well as the embedding models. We chose here a Google embedding model. This is the latest text embedding model 004. And for each table where we want to capture embeddings, we will do so. The books table does not require that, but the pages table where we split our documents, when we insert it, we're just going to insert into books with the same SQL, or if you use JPA, you save a particular object. And we would write the same code as we always did. In the summaries as well, and for us, it simplifies the developer experience significantly. On the consumption side, when we look at data, and we want to retrieve data, we'll find a let's say a sentiment analysis database, and we want to build our prompt. When we insert into the database, as you can see here, we insert the pages of a book. We will just write where is my insert? Here. We just write a simple insert. Insert into pages, there's no knowledge for us. It's being handled transparently for us as developers. On the consumption side, when we want to find information, let's say about a book, the changes which we will have to perform is only that the only change in our select would be that we would have to specify the model for embedding. And that is for us as a developer experience, it is much simpler to work with. Now, for Cloud Run, all we would have to do, and here we deploy the application in two ways. One as a classic JIT and one as a native application. So as a JIT, once we deploy it, we have to look at the configuration. We can easily configure things from concurrency of how we deploy an image and all the parameters which we have to set. If you look at Cloud Run, the image would be, we just pick an image. This is our image in an artifact repository. It's a container repository. We pick the image. We can, this is slow. We can configure it and we can run it. One of the things we should right away pay attention to, We're used to databases, to keeping databases in as secret. We don't want to put them in clear text. But keep this in mind because we'll need this later in the day. There are other things which we have to keep as secrets. For example, API keys. API keys should be treated in the exact same way as we treat secrets in the database. So we build the app. We know that we can deploy it. We can deploy in Cloud Run directly from source. In a production environment, of course, you would build it through a CI/CD pipeline. Each image in artifact registry is automatically scanned for vulnerabilities, and then you deploy it. We're going to look at how we configure that. But architecturally, this is how we start building it. Now, we're developers, so let's put a little bit our developer's hat, and let's think a little bit about it. We know that Python is the preferred language for AI/ML engineers. And that's because in generally providers of machine learning models have built things in Python. And that has a significant traction in that particular space, maybe in the LLM training space. But in the enterprise, when we build our application, Java is the dominant language of the enterprise. And I didn't put images all over the place, but I had to put that Python, which I picked this image from our colleague Guillaume here. So why should we pick Java with GenAI for this production app? It's reduced upskilling. If dev teams already have the Java expertise, it's a gentle learning curve. We are adding to it. We're not learning how to build a Spring Boot application or a function. That we know. We're just learning how to interact with an LLM. Then the integration with GenAI, there's a rich ecosystem of libraries, and this expands every single day. That is very easy, makes our life very easy to come in and start building applications. Now, performance and scalability, we were used to the performance with modern JVM tools and optimizations. Now, concurrency, and we talked a lot about concurrency in the later versions of Java. It's perfect for GenAI applications at scale. And in the end, it's enterprise grade, reliability and security and focus on large-scale app and the portability of you run it in a hybrid cloud, on-prem, in any cloud environment. Java is up for the task here. Now, how do we interact with it? If we take the interaction with, for example, models in the Google Cloud, do we want to write REST and program against REST APIs? We don't want that. We want to use maybe some providers or some specific applications will want to do that. But we as developers, we want to use our IntelliJ or VS Code or Eclipse or whatever tool we're accustomed to, and we want to program against a Java SDK. So the Vertex Java SDK allows you to work with Google's GenAI models to build your AI apps, but it's built for enterprise applications with security, with safety, and that includes AI safety, and we're going to talk about that, performance, and support. So we want to write that. Now, like with any SDK, we know that we have the ultimate control, but there's also maybe more verbosity in how we write code. So a couple of frameworks are emerging at this time, which would bring another level of abstraction and help us build applications faster. The first one is Langchain4J. It is inspired by, it combines ideas, although it's not a Java clone of Langchain, from Langchain and Llama Index and the wider community. It was started in 2023. I think last year here at DevOps was the first large presentation around it, and it has evolved quite a lot. It's a comprehensive toolbox for prompting and templating and RAG and document ingestion. And there's a growing sample base for developer onboarding. We contribute samples to Langchain or features as well. The other one is SpringAI. SpringAI was also started in 2023. It is similar in terms of the inspiration of LangChain and Llama Index. And for existing Spring, it brings the existing Spring expertise, which minimizes the developer learning curve. Now with Langchain4J, you can also build it on top of Spring and Spring Boot applications. So, and from that perspective, you have choices. Spring and the entire Spring ecosystem is battle tested in production, so it's the same premises on which they have been built, and there's a huge developer ecosystem for enterprise level applications. Now, which one do we prefer? We like both. We like that both of them are furthering this GenAI space, and the samples which we provide to you are built as code labs. They're 18 or 20 different little samples, and you can have the versions in SpringAI as well as Langchain4J, so you can have the choice. The main application we showed today, the larger one, is built in SpringAI, but it has its Langchain4J counterpart as well. So we want frameworks to help us as developers to help build applications faster. Now, when we build them, and when we build our applications, we also have to test them. You might be familiar with Testcontainers. If we look at the 12-factor application, now there are 15, since observability and a number of others have been added. Factor 10 is development production parity. So we want to develop and test with the same environments which we run in production. Many times we have used an age SQL in-memory database, and we select a brand from something. Then we run it in production and it fails because there it's random in Postgres. So we use Testcontainers to help us containerize a number of services which we would be using in the cloud. Google offers a number of them for which supports also like Postgres, so you can run it against Cloud SQL, Spanner, and messaging for PubSub. And where do we need that in our development space? Well, when we build with GenAI applications, we need to remember a number of things. Our responsibilities for in enterprise app remain the same. We still have to test our regular databases, our messaging system, our utilities. We still have to validate our requests. We always have to do that. That doesn't change. Now, when we add additional features like GenAI applications, how do we test them? Well, we can test locally with local models, and we can test with the models which we run in production. But we need to know that one of the areas, and we're going to look at it in depth in the second part of our session, models are different. They behave different. So we want to test our applications with the same models as we run productions. Yes, we're curious. We like to try different models. We run them. But if our application runs with Gemini or some other model in the cloud, that's the model we want to test against. If we run it, again, in an air-gapped environment, that's the nature maybe of our applications, where maybe in more sensitive sectors or public sector, or we built CLI applications, then if we test with local models, we should be testing and run with those models. So what should we test with Testcontainers? Let's think about what we actually need. So if we look at our tests, and we're going to run them, so let's run them all. We need to look into. We can test at the repository level. For example, we write the response in a NoSQL database, so we should test our data against Firestore. We have an emulator and a test container to wrap it. Great. We have to do that. We have SQL utility tests. We have built a number of features. We have to use those as well. When we validate our requests were sent, some were sent as notifications. Every notification in Google Cloud follows Cloud Events. Cloud Events is a standard. It's available in CNCF, and it gives us a consistent way of describing our events. So we should be checking that the ID and the source and so on of the event. These are validating the event, not the payload of the event. And we might have file utilities, but we're building a distributed system. So what should we do? Well, we're not building robust systems. We're building anti-fragile systems. So a system under stress should come back better than it was before. But in order for us to build these features, we also have to test these features that in a distributed system, a service downstream might fail. And that could fail because there was, for example, a loss of latency, a total loss of bandwidth. How do we test these errors? That is something which we as developers need to do, regardless how we run them in the cloud. Whatever fails there, we need to run these. Tests, and that is our own responsibility. When we run tests against LLMs, we use here summarization. We ran them against the actual cloud, not against the actual local model, because this is the model which we're going to use in production. So each one of them runs. We use test containers where we can. And please remember that if anything, test your application as you tested before, and test also all your edge conditions when you interact with LLMs. You might have a timeout on an LLM of, 30 seconds, which you might configure. You should test what happens in the application if that were to occur. Now, when we look at optimization simply, it's basic arithmetics. So the idea was that we always have to know about all the layers which we have to optimize. So when we look at it, what should we optimize? In previous applications, we would optimize the cloud runtime, then the Java runtime on top, and the different frameworks. We might be using Spring or Quarkus or Micronaut, the SQL access layer, and in the end, our application code. Everything is a sum. We cannot take them in isolation and handle them in isolation. When we move into the GenAI space, there are additional responsibilities for us to look into. What does it mean to optimize, or what does it entail to optimize GenAI frameworks? And how do we deal with vector databases? These are concerns which are on our mind. And there are various ways for us to look at optimization. We're going to take them in detail with some actionable items in the deep dive part. But one option for us to speed up our application is to adopt native Java images for our Java applications. If you're not as familiar with them, they're self-containable Java apps. They run without a need of a JVM, super fast startup time, peak performance. Nowadays, the latest features is on par with Hotspot, actually slightly better, and they have a lower CPU and memory usage. So let's look into some of the performance settings which we can set in here. One of them is, where do Java applications spend a lot of time at startup? A lot of it is in reflection. A lot of it is in proxying, dealing with resources, serialization, and that would spends a good chunk of our time. So Google added to Cloud Run a feature called Startup Boost. Okay, well, that's too much. So Startup Boost will double up the CPU allocated to the process at startup until the startup probe succeeds, plus 90 seconds. By this was introduced amongst others for Java applications, which would benefit directly of it, and for other areas where you have to load maybe models within your application. So CPU Boost will help you with this. But we cannot get the same performance. So if we look at how quickly our applications are, we could have minimum instances. So if we look at the startup, it takes 3.8 seconds, maybe sometimes 6 seconds, sometimes 5 seconds. We could still 3.3 seconds. So roughly, we speed it up from a regular Spring Boot app, which would take easily a 5-6 seconds on an ongoing basis. You can add also provisioned instances, resources, by which you would leave a number of instances in case you need like that instantaneous response, but you would incur a cost. For our application, we were told to be mindful for our university, we do not have to do it. In Google Cloud, Google Cloud Run is built on Knative. You can see how Knative is built, but it's not built on Knative. It respects the Knative interface, to which it adds a number of features, Cloud CPU Boost being one of them. One interesting feature, each time you make a change, it would result in a new revision. But we added this feature where you can change the number of instances without incurring a new revision, and instances which are executing requests in flight will happily continue to do so. But how about native images? If we look at native images, and while our network will come back to that, let's run our requests. If we ran our summary, let's pick now a sentiment analysis. We run this as a JIT image, and it would tell us for this book, categorize the book, tell us how who the main character is, and also give us some recommendations. So we can see this running. But if we were to run this against the native image, we would want to see a difference in response. Again, our time to the first response is instantiating that image, and instantiating the image, instantiating the application, and making the LLM call. So we can see that this is actually smaller. So if we look into the timing, okay, I want this to be faster. If we look into the timing for our service, let's see how fast this started. So if the previous ones with CPU boost, with a number of features which we added, started in 3-point-something, 4 or 5 seconds, now this starts in 0.585. I deployed that earlier, so it starts in 0.6 of a second, 0.7 of a second. This is not a hello world. It's an application with multiple dependencies, database dependencies, GenAI dependencies, and the speed is much faster with this. Versus, I love this. Versus the other one where we can see a 3.4, 3.8 seconds. So with all the best efforts which we did in the cloud, we can use native images. And this is what we use for our applications. So we made the decision of using VertexAI connected to AlloyDB. We use serverless. We can build the application. Of course, for illustration, we show them in both, and to see why we would make these decisions. Now, and that satisfies the business needs, and it satisfies also the operational requirements for our application. Now, how did we build it? What did we take into consideration? Good practices would always help us. We talked about testing. That is important. How do we abstract our code, and how much is there actually AI code. So frameworks would help us significantly. If we look at the interaction with Vertex, we wrote this class, and it has different features on how we would prompt with an image, how prompting a model, prompting grounded model where we allow the model to use web search, and prompting with function calls. So all of these, in total for all our 5 use cases, are in fact something to the tune of 172 lines of code. So tools, frameworks like SpringAI, like Langchain4J, help us significantly here. This class and the service class, we have different ways of interaction. So our controllers are not necessarily web controllers. They could also be invoked via events. So the controller should validate events but delegate to the service class. The service class is the only other class which is AI aware, so to say, and we can look at the dependencies. It needs the splitters which we want to use. We use some token splitters and documents because they are available to us. But outside of the service class and the VertexAI class, we have everything else is code which we could have written a year ago. And this makes our adoption very easy to use. When we built our code, we had also to be mindful of services which we use. So you saw that image, we take an image and we analyze it. But when we look into building, where is our image controller? When we built the application had to analyze an image, and once it analyzes the image, it will extract the text, it will get summary from the database, it will use different prompts. This is fine. But it needed that particular information, so we added functions to it. How did we implement the function? The function is simply a function which we're used to, Java util function. And in the function, we just created this service. So this service is just a function which will check the availability of the book in the bookstore. It has a request, it has a response, and it will be called by the LLM, and it will say, well, here's give us the book availability. 2 things are important here. One, these functions are easy to register. We're going to look at that, but when we build a native image, we need to be aware that building a native image does not know about this class. This is something new. It cannot understand it via reflection. So we need to give it some hints and register some types. The bookstore request and the bookstore response. Otherwise, our native image would fail. On the VertexAI client, all we had to, let's keep this up and running. If we want to use a function, all we would have to do is register the function, and we could register multiple functions in our call. So we build our applications as we used to build it. We add some new features, which we abstract and make a lot easier. We're going to get through some of the, we're going to dive into each of the options in the second part. But as a general application, what did we actually build? We build this application. It can run as a JIT and native image. It can run against the database. It can run against a model. We can change the models if we want to do so. And we can run this into the cloud. We can observe each of the features. We can see where data is stored. We can see the books. Very simple. We can see our summaries. which we generated, and we generated one from an existing document, one separately. One is for the Jungle Book, one is for the other book. Then we can see all the embeddings, and everything is easily at our fingertips. We can look at each one of them. So before we take a break and dive into several more concepts in detail in the second part, I wanted to open it up for question because I think now is the time to talk about what we did. So please.
Yeah, I have actually two questions. The first one is AlloyDB AI.
Yeah.
Is it open source and widely installed and used on premises, or it's only available in Google Cloud?
No, so there are two versions. AlloyDB, so in the past you had Cloud SQL, and you could run Postgres, for example, or MySQL. Right? Then AlloyDB is a clean implementation of Postgres. It's a managed service which is available in Google Cloud. For you as a developer locally, there is a new version called AlloyDB Omni, which you can download and run as a container on your machine. And you can run it as as you would be running AlloyDB. And I think that recently it has been added, or it is in preview, to add also function calling support to it. But you can develop locally if you want to do that. There is no test container at this time for AlloyDB Omni. I know like Google builds a number of emulators for large services like Spanner, a global service, right? Or PubSub. And there are like 5 of them which are available. There are more coming up, but if you want to use it as AlloyDB Omni, you can run it on your machine.
You can also run it on Kubernetes. There is an operator for Kubernetes as well.
The second question will be a bit complex. So we developed this application. It works on production for like some years maybe. We have a lot of embedded data stored in database, and somebody released a new model, much better model to do embedding. And I saw in the database that when we have a summary on some data, there is a model name next to embedded. If we need to do migration on production to change the model, I think we need to rebuild all vectors. How it works on real production usage?
So we're going to explore how we use different model versions as a best practice, because it's probably the first best practice which we have to take into consideration, how we use the different models. You see text embedding 004. That is the latest version. But if you would refer to it without a number, it will take always the latest. That's not something which you would want, because the embeddings, yes, they are built on, and you run your embeddings for a particular version. If you change the embedding model, you would regenerate your embeddings for a new embedding model. Now, when we play with something locally, it is not difficult to do. But when we look into the enterprise, we have to think first on testing. Like we said, we're going to test against the model in which we run. That goes for embeddings as well. If we choose a separate embedding model, and there are many available, some are for simple testing, some offered by various vendors, and you can simply use them. You can use a separate vector database. We took an opinionated choice, and after break, we'll show you multiple ways of how you would work with embeddings and why. Always the why. Why this or why that? So if you would work with a different model, you need to be aware that you would want to run your embeddings on the information which you have in your database.
So I should write migration scripts or application which will take existing data, go through new model, and update the data. Something like that.
Yes, you can do this in various ways. You can do this offline. You can do this gradually. There are various customers use it in various ways. Some are running it as a parallelized effort because you can scale up in the cloud. And if you pay only what you need, you can simply run a process in parallel, which you can run at scale on. Maybe when you have downtimes, depend the type of application you're building. This could be maybe running a few hours on, I don't know, Saturday night or Sunday night if it's a financial application. A bookstore, you would not want to run it in, for example, during exam season or reading weeks or before the school starts. But you could probably run it safely in a university on Saturday night when, maybe it's a downtime for the school. So you can choose that. On the other hand, you can choose to take a different approach on doing it gradually. But the first thing is you need to know why you're changing it. And you should be testing your existing tests against one embedding model and test against the other one because there are subtle changes. Of course, every model wants to bring new performance, but there could be differences. While the differences could not be significant, they could impact the accuracy and the robustness of your application.
How did you verify quality of the embeddings? So how you make choice? Should we move to different model or stay on the same model? What are the metrics?
Well, there are different ways in how you would. One, you have to test it. Now, one thing which influences a lot your embeddings is how you structure the information. We're going to get into, so if we are, let's say, in a bookstore, vectors will store information by their semantic meaning. If I say, this book is helpful to me, or this book saved my life last exam, would be in one, if we put it on a two, like it's a multi-dimensional space, but let's say on two axes, like helpfulness versus benefit, they would be grouped together. And if I say this book is terrible, it would be probably at the other end. But when you generate embeddings, you also have to think, what did you generate embeddings on? What kind of criteria when you also split up your documents? You don't want to do it arbitrarily, because if I take any sentence on a screen or in a paragraph, if I arbitrarily cut that, I might be losing semantic meaning. So you want to do it maybe by paragraph, by pages, by various things. That depends on your use case. As much as we would like to learn some good practices, in the end, everything is about finding a balance of how you would do that. Then, when you run your tests, there are various ways in which you can influence the response by different parameters or by the way you structure the information. You should be testing it, and you should have clear criteria. What is important to you? For example, in a financial services or a medical or a car information. If I have my car information, I don't want to see the yellow light telling me that it's something else, right? Accuracy is important. Whereas if you're talking about summaries or sentiment analysis, that is an area where other factors would come in. So the way we would test that would be slightly different. If we ask a question, what's the capital of Belgium? We definitely don't want to hear Toronto, where I'm coming from, right? So we would want to do that. But if we ask what is great about Brussels, for example, then there are different things. So how you test it and how you test between models, that is something you would want to establish. Any other question? Yeah.
Another question: how using native image affected the build performance? So, what is the reason you keep JIT images?
So.
Development experience.
So it's you keep and whether you build it with native or not depends on the characteristics of your application. And I'll give you some examples. Some applications, let's say when you run in Cloud Run, you run a service which could be interactive as concurrency. But there's something in Cloud Run called Cloud Run jobs, which is I give an input, could be an event, a trigger of some sort, event, like a message or so on, runs a job and it finishes. A job could take from seconds to hours. If you do a bin packing algorithm, it could be minutes or an hour. In that case, startup time does not matter too much. Now, there are other applications where cost is sensitive and you might want to have fast response. And you want to have also a good user experience of having the same performance of the first response or the last response. So a native image would allow you to have a fast startup. So it would allow you to have a fast startup for the types of application which you need. But when we looked at optimization here, maybe optimizing the cloud running time environment and the Java runtime can help us significantly. And if we looked at our logs, we had here like 3.5 seconds. If we don't put CPU boost, it's maybe 6 seconds. Right? That's what we're accustomed to with a Spring app. But there are other factors which come into play here. There's also the CPU limit and the memory limit. If we put one CPU, it's one vCPU in the cloud, and that's in any cloud. If you put memory of less than 2 gigs, to be precise, 1,762 megs, the JVM would allocate for us the serial garbage collector. So it influences what we do. So there are sometimes parameters, we're going to dig into that after the break. There are sometimes parameters which would help us with the speed. If CPU boost, allocating enough CPU and memory, brings us to an acceptable startup, then that's what you should be using. There are for JIT some choices, we'll discuss that as well. But if we want that ultimate performance, and you don't want to pay for any additional costs, then the native image would help you. You see this. This is not, these are running in the cloud, and we're in Belgium. This runs in Iowa and US Central 1. So it is, we didn't pick Europe West 4, which I think is closest here, or so on. So we want you to see it, how it actually runs. So this is an application. This is when it starts. So if you need that, then that's what you would be doing. If you build, for example, I want to have a little CLI, which should be able to help me tokenize documents or simply do some security checks. I'll build a CLI, and I build a native image, and I connect it to my local model. This is great. With a CLI, what is my expectation? My expectation is that this is fast. Whereas, and that's the ultimate thing. When I'm in the cloud, I have different choices. So I always have to think about it. What is important to me? What is important to my application? And that's how we make the decision. Right? So it's always a choice.
Does it affect also the build time significantly?
Yes. So yes, it does. So if we build an image, this application builds as a containerized image in roughly 20 seconds. The application itself may be 15 seconds. Let's give it 20, 25 seconds. When we build a native image, in a native image, at runtime, this is a native image which gets loaded. So the startup time, if I use one CPU or I use 3 CPUs, is the same because I'm just loading an image. I don't do reflection, I don't do clasp, I don't do anything. And we're going to see in the prompts why this is important. So we don't have to do this. So we do this analysis up front of every start from the main and every single known pass. Every single known pass is analyzed. And it's found. But what if it's not found? Then we add these hints to help out. Now this analysis is time consuming. It is time consuming, and if you run it, it could take, for this application, in a workstation I use, probably something around, I think like a minute 50, or a minute 50 or something like that. So that it could take also longer. It depends on the machine in which you're running. Now, should you build a native image each time? No, you should build your JIT image with Spring. There's this facility, other frameworks as well, to run ahead of time compilation during the build time to help you validate. Also, there's the GraalVM community. I'm a member of that community, has put a lot of effort. And from the build, there's an optimization flag, which just simply says, tell me if I could build a native image. More or less, I'm not optimizing for speed or anything. It's just a flag that's like, can I safely build it? If I can, then I can run it again with the ultimate degree of optimization. Yes, the drawback is you have a fast startup, but then you have a longer build time. We're going to look into the ultimate choices, like if we would have one single knob later in the session. Any other question?
Take a break.
Yeah. So then we'll take a break. In the second part, we'll go into some more advanced features, and we're going to look at best practices, and we'd like you to take them as, just please consider using them. Patterns evolve. As we learn about patterns, we want to see how patterns affect us here. We want to look at data at the core of our business, where our LLMs are deployed, how we run in a serverless environment, observability, as it becomes even more important, as now we have multiple, we interact with LLMs, and we have to know where we are. And then we'll leave a fun exercise for the end. So it is now 1:42. No, sorry.
That's
No,
the
sorry,
time
there's
left.
a time.
So let's do 3.
3 or 3:20, like a 20-minute break.
13 minutes break. So back at 3 p.m.
Okay, however you like.
Yeah, let's back here at 3 p.m.
So we're going to leave these QR codes afterwards as well available, but let's look into some interesting things here. First thing is, we started our session by saying that, generative AI adoption will be driven by business needs. So now that we decided that we want to do it, we want to switch gears. And we want to now adopt the GenAI technology which fits our project needs. So that's our focus for the second part. So as it comes down to what our colleague Gregor Hope, I think he has a session at the same time with us, he put this diagram when talking about enterprise integration patterns. And he said that in architecture, in general, you need to find a balance. Nothing is like black or white. There are different factors which you want to consider. So what is the first factor which we want to consider? And that would be choosing a model that fits our project needs. So in Google Cloud, in Vertex, you can select a number of models. Some are proprietary models, like Gemini, and it has different versions, Pro and Flash. Some you can use maybe smaller size models, which you can use and run them locally. But in Vertex, you can pick also open models, and they're provided by different organizations, and they're grouped by different modalities, like language or vision or speech, but also by the tasks. What is it in the end in our application that we need to use? We might not use only one model, so we might be using multiple models. So we need to choose a model that fits our project needs. We can pick, lately we added this feature that you can pick up any open source model from Hugging Face, you deploy it, you run it, so that's fine. But the important thing is picking up the model which fits your project needs. And how do we find that the right model for that project? We always ask ourselves some questions. Like, the more questions we ask, the better we can refine our choices. So the first one is, what specific task should the LLM perform? Like for the university, it might be summarization, or it might be text analysis, or it might be multimedia analysis. But for others, there might be different other aspects which are important. The second one would be, does the LLM's accuracy match the level of accuracy of your application? It very much depends of the type of application which we're building. So is accuracy in a car company or in a financial services important? Absolutely. We want to get the best, the highest accuracy as possible. Again, if we want something more creative, give us different opinions or on a different subject or different document or material, then creativity could be coming into place. But we need to know exactly what the accuracy level of accuracy is required for our application. When we build a GenAI app, we need to take into consideration the language capabilities of the LLM of choice. So we're asking the question not just for the language. We have this session here in English, but our app might be required in multiple languages, and not maybe a model might not support all the language which we need it for. But it's also the programming language. How easy is it to program with one particular language? So if we put, and we actually left our developer hat on, we need to think also about how what programming language, how is it supported? Now, when we run a model, where should we host it? We could host it in Vertex. It's a hosted model, but we can host it in other areas as well. A project has a budget. So what is the power consumption? What is the compute consumption of our project? How do we analyze this? We need to balance that. There might be different choices available to us, and we need to know how we're going to answer this question. So we need to know, where should we host it? We might want to run it even on-prem or in a hybrid cloud. So once we pick a model, there are some best practices which emerge into our app. And here, we don't talk about Cloud Run. Here's our Java GenAI app. The first thing is model versioning. So the best practice is use a specific version of the LLM model in the app, because the reliability and the performance of the model and its consistency is the top concern in our GenAI app. We don't want drifting behavior between model versions. So how is that happening? When we look into, let's say in Gemini, here's a drop-down, or we can look into a list. There are a number of models. If we specify in our application, we configure it with Gemini 1.5 Pro or 1.5 Flash, it will always access the latest version of the model at that endpoint. But in between models, there could be small variations. Sure, performance improves all the time. But what if there are simple changes which might affect our application? So the best practice is always specify the exact model. This simplifies your testing. You can test with 0.1 and 0.02, I think was added a few weeks ago, I don't know, months ago. It simplifies your testing, your auditing, and your debugging. You can pinpoint what version has contributed to that behavior. Yes?
If I don't specify the version and it's using a newer version later,
Yes.
will my what's it called, vectors still work? Like when I do the ingestion and stuff?
So for the vectors, you use an embedding model for that. In here, we're using an LLM to have a request response type of behavior in which we prompt for some request and we get a response back. The vectors don't come into play into this particular one, but your comment applies the same for vector embeddings as well. You should use the specific version of a vector, of a text embedding not like a generic version. Yes, it applies in equal measure there. Sure. So once we have our, we know that we will pick that particular version, we should also externalize it. Don't hard code your model configuration, because otherwise we want to change the new version, suddenly we have a new deployment. And in an enterprise, we go through the same process. Why should we change that when we can increase the application flexibility? It's easy to manage in one single point of configuration. You change the config, you don't change the actual application. Now, we interact with LLMs with prompts. So when we interact with prompts, we have two types of prompts. We have system prompts and user prompts. So the system prompts would inform the LLM about the context. So here we say you're an AI assistant and it helps people classify this text, and we give it some categories of text. So this system prompt tells the model how it should behave. So you're a nice, helpful assistant which can help me do these things. And that goes from user to user. There could be multiple system prompts by use cases, but for my use case, it's the same. But the users are different. So the user prompt is the end user input in the interaction. We ran that classification, that sentiment analysis book, and we want to see which category does this book fit in, and what is the name of the character. So this is our user prompt. But this prompt changes from user to user. So increase the reusability. I cannot make this faster, but I can show you in the code by using templates in your prompt. Now that we have the two prompts, we want to externalize these prompts as well. This is one of the most important things in an enterprise app. Don't hard code your prompts in the code base. Like, we learned how to export open API specifications for our web controllers, for example, and we version those specs and we govern them. We have our rules for them. Why shouldn't we do the same thing for prompts? And we should treat them the same as we treat code artifacts. It allows us to, we can track the evolution of our code, create an audit trail, and we have easy consistency. If we externalize them, so this is the same prompt. The lower part is an externalized one. It uses it in the application. The other one is hard-coded. Each time we want to change it, we have to change our code. So if we looked at our prompt, we should keep our prompts separately. So if this is the sentiment analysis message which we saw, and this is the user message. They're all separate. I like to group them if they're by different use cases, prefix them, easy to see, and they have templates. At runtime, I can just provide the regular the values I want, and that would do it. Imagine if we have like 10 or 12 prompts. Imagine if for each one we would have now to change it and redeploy our application. Now, when we control our model, we don't control it only with the prompt. The prompt has a significant influence on how the model behaves. We want to be as explicit as we can. And this is the same like in regular language. If I'm asking what you think about this book, you might be giving me a simple answer. If I'm saying, well, can you give me a particular, the top 5 ideas and tell me why I should be doing one or the other thing, I give it a different prompt, a more elaborate prompt. So that would elicit a different response. So prompt engineering, very important, but the content, the prompt drives the behavior of the model. But there are other parameters which drive it as well. One would be the maximum output tokens. In the response, an LLM as a context window for input at this time, Gemini models support, I think, 2 million tokens. And different models have different context windows. But on the output tokens, you have a particular number. I think on Gemini now it's 8,192 or so on. By limiting the number of tokens in the response, we can ask for shorter responses or potentially longer responses. That is something which we should test. Again, for our use case, each one of these parameters should be tested. We can't repeat it enough for our use case. The next one will be temperature. That's the most important one as it controls the degree of randomness in token selection. It is a number between 0 and 1 or 0 and 2, a decimal number, and lower values are less creative. 0 would be as accurate as you can, and higher, more diverse and more creative. Now, large language models pick always the next token in how they predict a response. So setting up top P and top K would have an influence here. So top P would say select the tokens by order of probability until a sum of probabilities reaches a certain value. So if we take in a general application, we take that the next word would be fantasy, and for books, the other one would be biographies, and fantasy has 0, 1, biography has 0, 2, and we specify, adventure or action, and also with 0, 2, and we specify top P as 0, 5. The sum of these three would be 0, 5. So we would select until cumulative, we find a number of tokens out of which you can select the next one. The lower has less random responses. The higher has more diverse responses. Top K is similar to top P, but it refers to a particular token. Usually if you set up temperature and at max top P, you can control the behavior of the model. Now these are set for every individual request, together with our prompt. And this is a snippet from SpringAI, quite similar in Langchain4J. We can specify the temperature, output tokens, the model we use. We also want here to enable Google search retrieval for this particular snippet. While we can control this, please remember that we talked about externalizing variable. Please don't do what I did here. I put this in the general app just as an anti-pattern, as please don't do this, because it's just going to make some people very unhappy. Now, when we build GenAI apps, we knew how to build our applications in the past. But now we're interacting with LLMs. And we build robustness in the applications with setting up guardrails. Guardrails could be of different sorts. So if we have an input to an LLM, there are some guardrails on the input side, let's say validation of various sorts. On the output side, we could filter the responses we get. So what types of guardrails do we actually need? Some on the input, we want to prevent harmful or malicious input. So we want to specify, we don't want to allow any kind of inappropriate language or unacceptable statements. So we want to be able to prevent that, and we want to set up these guardrails. On the output, we might get inappropriate content or subpar content, and we want this to be also dynamically adaptable, because let's say if I get a response with which shows a particular number of countries, I might want to send a notification. Or if I get some answers which I consider as not applicable, or they're not the right one, or I had to filter some content out, which means I don't want that, I could take the opportunity to send a notification to another system and say, well, what is going to happen here? So these guardrails are implemented in your application, so they run fast. So it's up to you to do that. One of them would be safety filters for the LLM. Here's a snippet from Vertex, directly from the Vertex SDK, on how we can block things like hate speech or dangerous content. And we have different safety settings. This is very important for us because we are responsible for not just for delivering a good application, but also of preventing unacceptable behavior in our application. It's an additional responsibility now that we work in the LLM space. How should you do it? Here's an example from SpringAI. In SpringAI, you can use, based on the old concept, if you're familiar with aspect-oriented programming, we had advices which could run before and after or around. They have this concept of advisor, and this advisor allows us to intercept a request or a response. So in the logs, we said mask data or prompt safety checks. Here we can do that. On the response, we can filter inappropriate response. Langchain4J has the concept of listeners, and you can do the same thing. With these advisors, the important thing is the order in which we execute them, because we could have multiples. I would say that the security one should be the last one for the input, so that if anybody changed the prompt in other advisors, the last one should be the security one. That's paramount as always to us. If we want to see how we implement them, very simple. One is, for example, a logging advisor. These are just for usage. I'm not suggesting that you should do this in a production application unless you parameterize this. You can log, for example, all the parameters, system messages, user messages, function messages, all the information in the request. You can do the same with the response. These are informational. But we can have a guardrails advisor, and we can do safety checks, or we can filter content. How do we use them? We just list them as advisors, and by listing them here, that sets the order, but we can also set up the order if we want separately. So for us, as developers, it's as simple as setting it up, but we should always work with project management and product management and other decision makers to know what security features we should adapt. For us, it's to provide it, and we should always consult with whoever makes decisions in our organization to ensure that we do the right thing. Now, what is the next step in here? And that's something which partially we can do now. Some things are evolving. This space is evolving very fast. As you know, I mentioned that Langchain4J was launched in public like virtually last year, like a year ago here at DevOps, SpringAI, I think at Spring 1 also last year. So one of the features which would help us significantly would be context caching. So it would reduce the cost of the requests that contain repeated context. Let's say we have an interactive app which talks about, let's say, our sentiment analysis. We might change the words, we might run different things. So it's the same large document. Or it could be a video file, or it could be an audio file. All of these could be cached so that we don't change for the small amount of data we change. We don't have to pass in the same information all the time. This would help, of course, defray some of the costs, because you're passing less information. Of course, there's a cost for caching, but it is a cost saving for a user. Gemini supports this at this time, and there are other models who are supporting this as well in various ways. Gemini supports that at this time. The other important thing which is in our power to do is response caching. So we can improve the performance significantly if we cache some of the responses based on exact input. If we look out at our app here, and sure, this was getting data from the database, but if we run it and we run a model in GKE, it should give us a response. That's great. If we run them over and over again, they might give us the same response. This is very clear. I want a quote with a name, an author, and the quote. I don't know if I run it a few times, it might give me the same quotes. Well, it doesn't want to play the randomness game. But we could simply cache these responses. And performance is great because we just pick a value from a cache. And we know how to handle caches. And we would respond that input. We would return the same response for the exact input. But sometimes searches are slightly different. So we want to cache responses based on similar but not identical input. And we could do advanced caching with similarity search. In the Google Cloud, you can store even in caches or in databases, in SQL, NoSQL, memory store. You could do that if you choose to do so. So keep in mind and keep an eye on the evolving space of context caching, and response caching is something which we can do at this time ourselves. Yes. Response caching is up to you to implement of how you choose to do so. Context caching, for context caching as it is implemented as in Gemini, you can decide what you want to store as in the context cache. Let's say I have all of Shakespeare's works, 5.5 megs of data on Gutenberg. I can take that. Should I send this with each request? No. So in the first interaction, I can store it in context caching in Gemini, and then I can send my request and do that. But that's on the input side. That's where we work with the LLM. On the response side, that is up to us. We can implement them with existing things. When I got these cache values, I could have saved them in memory store and save them in the cache, or even I shouldn't save them in my local application cache, but I can do that. And first I could check. But that's up to you, how you would want to do that and how important it is, again, for the use case which you're trying to address. There might be more significant things. That's why, for example, summarization. We don't want to run summarization each and every time. And that's our next topic. We don't want to run it. Should we cache that summary? Yes, we can put that in the database because it's a longer operation. Even if somebody asks for the summary of that book, that's cool. But if it's something like maybe quotes where somebody might just want to insert an app, I want a quote from, I don't know, George Orwell or whoever, then in that case it would apply. So again, judge it by your use case. There are several other, some I covered here, but there are several other best practices listed in this blog from our colleague Guillaume. Please take read this and look at it. He addresses it in many more things in more detail. But in the end, we have to think that we knew all these best practices from before. We should not forget them. What we built in the cloud yesterday is not forgotten. But we add new things, and they can influence how we work. Now, we learned to use patterns from the old days of like the Gang of Four to enterprise integration patterns. Now, when we move into the AI space, things are new. What is the right solution for us to solve a particular problem? So we like to think that AI patterns are the architects of intelligence. These patterns emerge in this space. So they emerge, and we want to take one pattern because we used it. We want to give this as a blueprint of how to think about it. So let's take summarization, the simplest thing, prompt stuffing, large context window in Gemini, 2 million, please, add whatever you like. Well, the document, when should you use it? You take a document, it fits in the context window, it summarizes the entire document in a single call. with Gemini and produces a final document. So there are some pros and cons. One would be there's a single call to the LLM. It's most likely faster. We pass the entire input, less networking, if nothing else, and one single call. The model has access to the entire document at once, so potentially it could yield better summary results because there's no splitting, everything is available at once. The cons is the document must fit in an LLM context window. If you use a model with a smaller context window, your content might not fit in there. But this is the simplest thing we could use. We're going to run them all. Now, the second one is an evolution. It's MapReduce. We're familiar from the big data world with MapReduce. So in MapReduce, we take a document which does not fit in an LLM context window. We split it in chunks, or we actually chose to take a MapReduce, not only because of size. We take the different chunks and we prompt the LLM to summarize each individual chunk. So we map a document to multiple operations, which we can run in parallel, and we produce a list of summaries. So this is the map part. In the reduce part, we reduce the list of summaries and we pass it to the model and we ask, please create a final summary in the last call. So this produces the final document summary. Well, there are some pros and cons as well. Pros would be that large documents can be summarized with smaller context windows. The overlapping chunks can improve the summary accuracy. So when we split them, we don't want to arbitrarily split a chunk, because if we split it by 1,000 characters, then that might lose meaning. So should we do that by paragraphs, which fit into that window? What are, if we're inefficient, or we put 1,000, we used 800. What should we do with the rest of 200? So we might use a sentence splitter. So fit as many sentences as you can. But now I have 2 sentences in one chunk from the same paragraph, 2 in the other. So the original author has now wanted to convey a message. That message might be lost. So we define an overlap window so that we can avoid loss of significant meaning for what we're doing in the summary. So that is something which you would be testing. It's not just performance would affect it. Smaller chunks, of course. Smaller chunks would be giving you a lower performance because you have a lot more operations to run with. Now the cons would be, you can run them in parallel, but the cons would be that you have to run multiple calls, and this arbitrary text splitting could lead you to content loss. There is another option, which is also one which requires splitting the document. It's a refine alternative. So we split it in chunks. We understand how and why. And then we want to summarize the first chunk. We have one summary. Then in the second operation, which we have to repeat until the summary with all the subsequent chunks have been processed, we take the summary, and with the next chunk, we pass the summary as a context and summarize them both. Then we repeat. Now we have 2 summaries plus, actually the previous summary, plus the new chunk. By doing that, large documents can again be summarized with smaller context. The context is preserved between chunks, so potentially you're improving the accuracy and the completeness. Use overlapping chunks again as well, as we discussed, to improve accuracy even further. The cons are that multiple LLM calls are required. You must execute them iteratively, and it doesn't lend itself, obviously, to parallel processing due to the interdependent nature of the individual chunks. And the latency is significantly higher than in MapReduce. So if we take this summarization, and we implemented this here as a test, Let's run this. And while this executes, we want to see if what we are saying actually makes sense. So how do we interact with it? Let's stay, and here, sure, it is a test. I hard-coded the config, not the config, the prompt for this one. It's a separate test app. And we give it a system message. Well, reply as a literary critic and ignore Project Gutenberg references in the summary because we know that's not something we're interested in. And there's no legal issue. But the user message says, please give me a summary no more than 10 sentence bullet points. So, okay, so this is not more than 10 sentence, 1 bullet points. That's good. If we take a chunking approach, the chunk would have a different user message, while the system message would stay the same. The user message would say, well, write a concise summary of the following text between these quotes, and take this also context available into consideration. The first time, the context is obviously empty. The second time, it's not. And in the final summary, we use the same user message. So please give me a concise summary, and then take also this content. What do we see as numbers? I don't think I can make this larger. So stuffing took 8 seconds, and it took 8 seconds. MapReduce took 19 seconds. For this, we don't use the Jungle Book. We use the Wasteland by T.S. Eliot. And this is not a large document. We split it in 4 chunks of size 10,000 with an overlap of 500. And the MapReduce took that much. Refinement, and we print how long each one takes, is the same, of course, chunking, but it took a lot longer. We can determine how many tokens we used. So this uses, we can run a call in SpringAI against the Vertex SDK and see how many tokens are in the text. And sure, billable characters in the text. But what we see is, we see stuff takes 8 seconds, 19, and 33. Sure, depends, of course, on the text. And when you use that, as with any other parameter, please externalize both the chunk size as well as the overlap size. So you can see when we start from addressing a problem, summarization seems to be like cool and simple, but we have different options. These patterns emerge. We are all lifelong learners, let's be honest, and we're curious by nature. So we should learn what other patterns will emerge. And there are many others. We just took this example as it pertains to the app which we had before. There is a blog for this. I showed you this in LangChain. Of course, there was a SpringAI version there as well. But there's a blog post here which you can see these all in actions. And of course, everything comes with full test code and instructions for you to run them. Now, when we run them and build and test in serverless environments, let's go back to the optimization and our ideas of optimization. When we look at the cloud runtime, let's take some of these recommendations. They have been used and reused many times, so we would highly recommend that you take them into consideration for your next application, if it's a GenAI app or not. They apply equally. So in the cloud runtime, you can increase the number of allocated vCPUs. As we said, you give it 1 CPU, you give it 1 gig of RAM, you're getting the serial garbage collector, you run a few requests, and then suddenly, oops, this is not working as we want. You can choose different runtime environments. In Cloud Run, there are 2. One is optimized for faster startup. One has faster networking and faster, it's a faster CPU. Then you can use CPU boost. It's a very almost, I mean, it's very inexpensive as is, but just adding it for the startup, please use it. There's nothing to be tested or retested. It's a very safe environment. Once with one of our customers, we enabled it enterprise-wide before a major sales event the night before. One simple thing dropped startup latency significantly. Tune the minimum instances wisely and proactively. Minimum instances as provisioned resources. If you want to use them, set a few, use them, but always know why you would want them. Do I really want to have an instance which should not have a startup at any time? Well, even that instance gets restarted automatically when certs are provisioned, but you always know that you have one. Match memory to concurrency. In any serverless environment, we can set up concurrency of requests. Now, each one carries memory costs. So always ascertain how much do you need for each particular service. I'll say service rather than microservice, mini service, or so on, for each service. Now, in the JVM, use the latest LTS version. Sure, 23 just recently released has some very cool features, 24 even more so, but in production, we would always run on an LTS version. Don't rely ever on the Java ergonomics. Set them yourself. When you set up the memory, don't hard code it. XMS and XMX, that's not for the containerized world. Set them as a max RAM percentage. If you set it at 75, 80%, for most cases it's good enough, but you can tinker with that. That's good enough for the majority of the applications. Set the garbage collector explicitly. We can see what happens if we have a small one, and reduce the thread stack size. By default, it's 1 meg. We probably don't need that. You can safely reduce that. But again, know what you're doing in each one of the threads. In Spring Boot, of course, because we built Spring Boot apps, you optimize the class path scanning and dependency management, fine-tune logging. If you have actuators set up, they're great, but don't use more than the actuator endpoint you need. The ones which you should always, if you should always have, if I take the image, where is it? Of course, if I would know how to, I really don't know how to type. Why am I not surprised? It's processing. When we start our service, and each of the classes tells exactly what it will do, this controller is ready to accept requests when it has been initialized. So once the controller is initialized, we can set up a startup check and set this up. And the actuator should check we can configure startup and health. And we need these two actuators because we want to have an accurate startup, and we should set them up in the application. And you can set up the startup and the liveness probes in Cloud Run, and you should use them. But don't use things which you do not need. Of course, avoid class path scanning, and limit unnecessary auto configuration. Don't use like the auto art. Just specify exactly what you need to do. Now, in your application, eliminate, of course, unnecessary dependencies, but minimize the container image as much as you can. Layer your images as you build them. Avoid calling other services during startup. Many times in the past, we would build up apps on the app server and try to keep them up for a long time, and we would make call to get references, well-known data at startup. And that is not really something beneficial to us, especially when we're in the cloud. And then we load data. You recommend it. Don't just use it from databases. If you need some cache data, load it from a cache. In terms of your configuration, always be aware of what you're setting. We set up the garbage collector, we set up max RAM percentage, the active processor count. use secrets. Why do we set up the active processor count? Well, this is important. If we set up one CPU and 1 gig of RAM, every cloud compute service will report to the JVM 2 processors, because Java application, that's primarily came from the Java world. It will generate, it has garbage collection, so there will be 2 threads in use. If you specify this as 1 gig and the JVM gets 2, and your app, amongst other things, reads events from PubSub and then calls some LLM and does something, now if you do a full subscription, if you do it by how many threads you have, now I create 2. But I have, actually it's only 1. From 2, 4, 8, they're always reported actively. But as a good practice, set them always there. You know exactly what you configure, and everything is configurable. When you deploy it, very simple how to set this up. And as a startup probe, you can tune that. You can leave it by default, after how many seconds it should start, what the timeout is, how many failures, and you can tweak that, and you can pin that to your health probes.
I have a question.
Absolutely.
If you have a pod that has like less than 1 CPU, like 500 millicores, what do you set them as active processors?
You know, at first I would ask the question, why would you actually set that low of a value for the application? Of course, it depends on the type of the application. Why would you set it?
Because most of the time it's enough.
So you, on a VCP, you're allocating only 500 millicores. Are you considering a single threaded application, does one task, it's done, or are you considering a concurrent request being handled in your service? First, we should think about it, redundancy notwithstanding. Of course, in an enterprise, we always run 2 instances, or in Kubernetes, multiple pods. We should do vertical scaling before we do horizontal scaling.
Yes.
That is a cardinal rule. Again, redundancy notwithstanding, you should have always 2 at the minimum, but then you do vertical scaling rather than horizontal. Because imagine when we load up memory, we have what do we load up in the resident set, in RSS? Load up the classes. Why should we load them in multiple instances and then lose space? In the cloud, everything, and in every other application, there's a price to pay. So we can have more dense deployments if we choose to. With native images, even more so, because we load only exactly the classes we need. So I would recommend that you would consider multiple instances for redundancies and then scale up vertically. And now there are, you can see the advancement in garbage collector. G1, GC would be probably the best for the majority of the applications. But there are new ones, like ZGC will minimize, for example, the interruptions. Right? So consider that. Sure. So if we were to have choices. On the JIT side, if you were to pick one solution, the recommendation would be use Java 21, use GraalJIT and AppCDS. So, you know, we had OpenJDK, but GraalVM has 2 versions. It has, you can run the JIT portion or the native image. GraalJIT by itself is by several percentage faster than the OpenJDK. The Graal team is here in several sessions. They will mention that. I don't want to put percentages in and speak on their behalf, but please use that if you build a JIT app. Now, class data sharing was available for some time, but a lot of effort has been put now into web frameworks on application class data sharing. And it influences the performance of your application significantly. From the app I deployed now, I did not build app CDS inside. The previous revision had that, and it shaves another 500 milliseconds to a second from the start. So this is production ready. It does not change your code. App CDS does not change your application. It does not store secrets or anything in the profile. So consider that. If you would have one knob for your GenAI app, say there's a single choice. My choice would be, and we tested it out. Abdel and I had a session at Spring.io, and we actually proved how this works. You build a GraalVM in native, use profile-guided optimization, which is this. Consider this like I gather a profile, I save that, I build a native image with that profile inside. So it gives me both startup as well as performance like hotspot, the G1 garbage collector, and the highest level of optimization. For a production application, this would be your best choice. Now, the last thing I want to touch upon here before handing this over is data is at the core. Data is at the core of our application. So we talked about embeddings and how these embeddings would be stored. If we put here sentiment versus satisfaction, I love this book, and this book makes my life easy. It's on one side, and textbooks on the other are arrived damage on the other side. Okay, so we have these embeddings, and we have now to store them. So how many choices do we have here? We showed you the choice we built for our app, but that is our opinionated choice. Let's consider the options. If an application sends a user prompt, the application, user sends types in something, here's the user prompt, the GenAI app would now first have to go to the embedding model, get the embedding, look in the vector store, then retrieve separately enterprise data, and in the end send the entire user prompt and the relevant data. Vector stores are purposely built databases. They're optimized for vector embeddings. They have their pros and cons. What is happening here? We have 4 different interactions with the LLM to retrieve our data. An improvement would be if we use a PG vector database, or a database, for example, in here we use a PG vector database, a database which has vector capabilities. Now, we still have to deal with the embedding models to generate it, but we retrieve embeddings and enterprise data at the same time. And then we send the user model. So one less database to manage, one less hop to deal with. And in the last one would be if you use the choice we have of using AlloyDB integrated on the back through the Google backbone to the embedding model, you make one single call to the database, and then you send the user prompt. So we go from 4 different interactions to 3, and then we're down to 2. The differences could be from management, well, performance, of course, but the management, the effort we have to do, the knowledge we have to upskill folks, and the effort which we would have to do in building and maintaining the applications. You saw what it took for us to, and how the DDL was set up and how easy it was. If we take one of the code lab samples and we run it, this runs into individual parts. So first we have to, of course, store the documents, but we split the document, and now we have to do a similarity search. Then we have to search in the database. In this particular local implementation, we pass in the embedding model, so it's doing it in this memory, does it under the hood. But it's the additional step. And then we build a template and then we call that. So we can see each of the steps. So this is something which you should consider for the applications for which you are building. There are many factors here, and cost and total cost of ownership has a significant importance here. So let's switch now to how we balance control with operational simplicity and see what does that mean. What does that mean to us?
All right. I just make sure that it doesn't get discharged. So most of what Dan have been talking about so far is basically the architecture of the application and the considerations for databases and all this stuff. But there is also another thing that you have to consider is where you're going to run your model, right? The model itself is an app and it has to run somewhere. It needs compute, it needs storage, it needs hardware accelerators. On Google Cloud, you pretty much have 3 options. Let's say 5, but we ignore 2. The 2 others would be either run it on a VM, right? Or the most recent addition is adding Cloud Run with GPU support. So you can run your model as a container inside Cloud Run and attach GPU to it. And that would give you a serverless GPU. I'm putting serverless between quotes, but it's serverless GPU experience. One of our colleagues, Vitse, has a session here on Thursday where he's going to explore that in details. But for the purpose of this presentation, we'll focus on the 3 options that Dan built the app with. So one of them is running on VertexAI using Gemini 1.5 Pro. So that's essentially invoking Gemini through VertexAI. So that's the Google model, the most capable one, big context window, etc. But on VertexAI, there is something called the model garden, and you can choose a model from the model garden and deploy it on a VertexAI. So VertexAI offers a hosting service for your model. So it will run the model and give you an API endpoint, and then you can interact with it. In this particular example, we're running Llama 3.1 on VertexAI. The third option is to run on GKE, and that's where whatever model you want, you can just run it as a compute or on GKE. So if we go back to the app that we have here, which should be over there. So we have the 3 options here. If I invoke this one, that's invoking Gemini Pro via VertexAI. This one is invoking Llama running on VertexAI. And then the third one is invoking a Llama 3.0 running on top of GKE. So if we quickly check the code for this particular application, that would be in the bottom here. Yeah, sorry. I know where it is.
Even more.
Even more, yes, it's there. This is there we go. So this is the code for the app running on top of VertexAI. So just using Gemini through VertexAI. We pass some system instructions, user message, and then we get a response, right? Then we have the one running Llama 3.1 on VertexAI. So that's an open model running on VertexAI. And I wanted to show somewhere here that we have in the raw source application, this is the endpoints that we specify. So once you deploy a model on VertexAI, you get basically an URL endpoint, and it uses our standard authentication method for authenticating to that particular endpoint. And then the third one is using GKE. So this is you deploy cluster, deploy GKE on top of it. One thing I want actually to show before I move on is this particular example here, which is Llama 3 running on VertexAI. VertexAI gives you an open AI compatible endpoint. So we are not using the VertexAI endpoint or the VertexAI, like the spec. We're using the OpenAI spec. So even if the model itself is hosted on our platform, we are exposing an OpenAI compatible interface, right? API. So this is why we are using here the OpenAI chat model from SpringAI. So let's look a little bit about the pros and cons. So managed solution would be either VertexAI with Gemini or VertexAI with an open model. It's very easy to use, very easy to manage, very easy to deploy. Scales up and down automatically, and it's optimized for resource utilization. all the updates, all the patches are managed by us or managed by the provider, so you don't have to worry too much about that. It has very, very tight integration with other Google Cloud services. Since everything is in Google Cloud, like all calls between APIs are quite fast and the integrations are pretty good. And it has built-in compliance and security features. The downside is that you don't have that much customization into the infrastructure itself. So when you are deploying on VertexAI, you can choose the type of hardware accelerators you want, GPUs or TPUs, but you don't have that much options in terms of fine-tuning the compute environment itself. There is a potential vendor lock-in here. Let's be honest about that. It could potentially cost you higher because basically you are charged per, is it per token or per invocation?
It's per token.
Per token, yes. You don't have, as we said, less control over the infrastructure, and you potentially, well, like we do not support all the open models on the VertexAI option, right? Deploying an open model on VertexAI. And I was actually looking earlier, even the OpenAI compatible interface is only supported for a few models. It's not supported for all of them, right? And this is how the architecture of using VertexAI would look like, right? You will have your user talking to a load balancer, talking to the application itself running on Cloud Run, so the interface that you saw that's running on Cloud Run, and then it invokes a GCP endpoint, which runs on VertexAI, on which we deployed something from the open model. So that's a Llama 3 example. Now, on the other hand, you have the most flexible option, which is running on GKE. And off the bat, I'm going to start with a statement. Kubernetes is not the most developer-friendly tool out there, right? It was not designed for developers. It was designed for people like me, who came from infrastructure background. So we do have an option for you to use GKE in an easy way. We call it GKE Autopilot, which is a fully managed version of GKE. And that probably should be your first option if you want to double into Kubernetes, generally speaking. Start with GKE Autopilot, and if you hit limits, then move to the standard mode. So this gives you full control over the deployment. Potentially could cost less, especially that GKE and GKE Autopilot has a lot of scale up and scale down, auto scaling up and down features. GKE Autopilot actually, if the cluster is not used, it will scale down all the way to 0. So you only pay for the control plane cost, which is not that much. You can pretty much deploy whatever model. You can even actually use the Ollama container to deploy a model on GKE. It's great for portability because us and all the other cloud providers, we are just exposing a Kubernetes standard API. So the same way your model will work on GCP, it would work on other cloud providers. And you have fine-grained performance and resource optimization. So you can like tweak it. You can do 520 milli-CPU, as was mentioned earlier. The cons, you need expertise. Managing Kubernetes, again, as I said, Kubernetes is not a developer-friendly tool, so managing Kubernetes takes time and effort. And the learning curve is quite steep. You will be responsible for updates and security, right? Because to run something on Kubernetes, you need to take the model, you need to package it inside the container, and then run that container. So if there is updates, then you have to update the container, so it's pretty much your responsibility. If you want to do auto-scaling, you will have to do still some manual tweaking, especially if you want to integrate auto-scaling based on the load balancer metrics. You have to do all the compliance and security yourself, and yeah, it has a higher initial setup time because, Kubernetes. This is how the architecture looks like for the Kubernetes example. We still have UI where the application is running on Cloud Run, and then in the middle we have the GKE cluster. So the GKE cluster runs, in our particular example, we're running vLLM, which is one of the inference engines that exist on the market. You could do TGI from Hugging Face, you could do Ollama, you could do whatever other inference servers you want. We are attaching some L4 accelerators to this particular cluster, and then we still use a base model that we're getting from Hugging Face. I can quickly show you how that looks like in practice. It's there and it's there. So that's basically how the deployment looks like. Just standard Kubernetes deployments. We have some L4 accelerators in here. We have some tokens because we need to download the weights from Hugging Face. And then we start a very standard, so this is the vLLM server itself. And then once we started, we tell it which model to use, and it will download the model and start it for you. And then a bunch of arguments, blah, blah, blah. And then at the end, we have an ingress object. So this ingress object here is basically this load balancer that you see here. So this is actually something I've been discussing with Dan yesterday. Like, setting this architecture this way, you will have to protect this endpoint. You don't want this endpoint to be exposed to the internet, because an ingress object in Kubernetes will generate a public load balancer. So he set it up such a way that there is actually an authentication mechanism for the Cloud Run application to be able to call the GKE model. So you can see, like, when we say complexity, it's also complexity in terms of how to secure it and how to make sure that the model is not just open to the world and people can just talk to it, right? So we have a blog here on all these options. Dan and Yanni worked on the blog, and they went through a lot of details into how can you, like, all the considerations to choose where to run your AI model, right?
And as usual, it's an evolving space, so please keep an eye on it, like exactly on support on the OpenAI API. Things change. So what we do now, I'm sure we're going to update this app probably 3 times by the end of the year.
Yeah. So now, observability. I mean, when we build apps, we need to make sure that we know what they're doing. So observability is important. We do have few options on Google Cloud with something called Google Cloud Ops. We used to call it Stackdriver, and it has a lot of features for monitoring, for tracing, for logging, etc., etc. We built this example, Dan built this example, where in the code base or in the code sample, there is actually a whole, no, it's here, the Docker Compose one, yeah. So there is a Docker Compose file which will set up basically everything locally. So it will set up Postgres, it will set up Grafana, Prometheus, it will set up all the tools needed to do monitoring. So let's look at it here. So I have, of course, we have the app itself running. I need to go find it there.
2 tabs to the right.
2 tabs to the right?
Yeah.
Yep. So this is the app running locally. So this one here is running on Cloud Run, and this here is the same app running locally. So it has the same thing. It will talk to VertexAI, Gemini through VertexAI, or Llama through the open models on VertexAI, or the model on GKE. And so we have a Grafana interface here that we can look at. And we can see, should be this one here. No, this one. And it should have a node graph. No.
No, I think the search is not. Oh, okay, yeah, that's fine.
Here we go, yeah. So then we see here, we have our node graph. So we have the exact call order. This particular application, we are actually, for the example where we are calling the model on GKE, we get the response back, and we run it through an evaluation service which uses Claude and Sonnet, the model. So let me show you that in the code. Here, if we go to the LLM here, so we have the prompts, we have we call the AI, we get the response, right? And then we run it through a sanitization service, which uses another LLM. So it's like an evaluation service. Here, and this is this one here, which uses Sonnet to sanitize the response, right? So this is particularly done to be able to show this kind of things. So we are doing basically 2 LLM calls, one after another. So we call the application, calls the chat, the Llama model running on GKE, and then after that calls Claude, and then we can get this nice call graph. Where we realized earlier that the order is not correct. So the bottom one is the first call, and then the second one is the second call. And then we get all the metrics that we need, like how long each call took. And then we can visualize it, and you can like figure out if you have bottlenecks in the applications and stuff like that.
Bear in mind that instrumentation is done in the AI frameworks. And SpringAI offers instrumentation for several models, but not for all the models which you can use for chatting or so on with SpringAI. So, for example, we used Sonnet and Llama because Gemini model is not instrumented
Yep.
for observability. So by this, you can see different models at play. Again, follow the next version in a week or so, we'll have that. So things change.
Yep.
Your code doesn't have to change. Its instrumentation will be available to you.
Yeah. And so, yeah, so this is just examples of how you can figure out where does your request go, right? Traceability. Then, I mean, as I mentioned, as an infrastructure person, I should like Terraform. I have to admit that I don't, but that's just beside the point here. But as somebody who does infrastructure, I came from then I need to find the scripts. Here.
Yeah.
No, this one first. I came from this. I came from Bash, right? So this for me kind of speaks to me. I know what's going on. Use the gcloud command to set up some stuff. But this is probably not going to speak to everyone, especially not a developer, right? So Yanni, our colleague, figured out, can we actually use a model to feed in scripts, Bash scripts, and get Terraform out, right? And to build this, he actually used RAG with, what is Postman?
Postman is there.
Yeah. So he used RAG, and well, first of all, I want to show the embeddings first. Let's look at the database itself. So what he did is he...
in the pages.
Yep.
Yeah.
I'm just going to get the books. He actually took this book called Terraform Best Practices and used an embedded model to chunk the Terraform Best Practices book. And these are all the pages across all the books, but somewhere here we should be able to see Terraform somehow, right? Terraform samples demonstrate.
It's a book
blah, blah.
with book ID.
Yeah, it's a book ID 8, right? So then we have a vector embedding, right? And then we can use RAG and a model to be able to basically give it Bash scripts, ask it to transform it into Terraform scripts, but also ask it to run through the embeddings to make sure that the Terraform script follows best practices, right? And so that's the endpoint that we have here. So as an input, we have the Bash script. That's the Bash script I showed you earlier. And it will generate an output, which is essentially Terraform code, right?
So
and this...
That includes the startup here as well.
Yes. So we will leave it running for a second, and we can already look at the results somewhere here. So that's... no, not this one. And the back one. No, behind the Postman, right?
Yes.
Yeah, here. So then we have the Terraform scripts here. So it generates Terraform scripts for that particular script, like Bash script that we give it as an input.
The project itself, the code base, has all the gcloud commands like Bash scripts. I'm coming from the dev side world, so for me Terraform even more difficult. I admit I shouldn't. But if you want, you can use that endpoint and generate the Terraform scripts if you find this as a helpful or fun exercise to do.
Yeah. So we can take a script like this, and thanks to AI, we can generate Terraform code, right?
And it generated with accuracy.
Yeah. So we have an article which goes into details about how the application built, and as usual, the code itself is available on GitHub. And that's almost it.
Yep.
So we'll leave this up for a few minutes, so you can grab the code base and the code lab. And
ask any questions you might have.
We're open for questions. We have 13 minutes left. Thank you very much.
Did you consider using something for prompt management like length views?
I didn't hear exactly the question.
Did you consider using length views for prompt management?
Lang views for prompt management.
No.
We do have something for prompt management on VertexAI. There is a service for doing prompt management on VertexAI. I forgot its name.
So for prompts, if you think about it, treat prompts as you treat code. Treat
So the versioning, etc.
Yeah.
Analysis, like making green-blue deployments.
So in the end, for the time being, there are no standards which have emerged. You see, for observability, there's instrumentation on the library. But there is an effort in OpenTelemetry to standardize what information should be there. For the time being, that is not available. So it does not depend on us. We would love to have it. But we have to be cognizant of this fast evolving space. On the prompt side, sure, prompt engineering is almost emerging as a discipline. But there's no standard of how you would do it. Like, you would be surprised. You see a lot of prompts hard-coded left, right, front, and center. And that's why we feel that it's so important for us to talk about externalization and how we should test about, how we should go and test things. I'm sure testing efforts would be, as much as our patterns evolve and our trust in these systems evolves, testing would be paramount for us, as we have to establish what the criteria of acceptable response is to us and behavior. You can see, if we use function calling, we can get very precise information. If we use things in the financial sector, where we might want to get an analysis of some financial transactions, then suddenly there are multiple things. We have to consider PII. We're not going to send that. We have to use function calling, because you can specify transaction 1, 2, 3, but you have a function which would have to resolve it, because it's your own data. It's your responsibility to your own customer base. So if you think about it, how would you test that? What does testing mean? What is the accuracy? What are even the guardrails which we have to set? When we talk about robust, we don't build apps to survive like we did in the app server. We started the WebLogic. I was a BA architect many years ago, and you build an app to stay there up for days and weeks. Now we build for disposability in the 15-factor apps. How quickly can I get back to the state I was before? But robustness takes now a different meaning. What does is my application robust? Am I creating suddenly security hole or social behavior failures? So these are all things which we have to consider. What we brought this session here to draw attention to there's no one solution for everything. Some things are very clear, like use this native with PGO, great, right? Or do a number of things, sure. But the majority is, we have to ask ourselves always the question, why did we make this choice? How will that affect us in the enterprise? Because it's different than our local curiosity. I tried different things. I'm going to try several other things probably in the evening in the hotel. But that doesn't mean that tomorrow that makes it in production. We have to, as we were responsible for our apps, by adding some features, when we need them, we add them, but it brings more factors for us to consider. And that is very important to us.
Yeah, VertexAI has a way to do prompt management. It doesn't have an API yet, or I don't know if they will plan to put an API on top of it, but there is like a way in the GUI, in the graphical user interface, to be able to like save multiple prompts and try them out and see what the results were. And they added very recently a feature for like prompt comparison, so you can try multiple prompts against the same model and see what the answer will be.
Yeah, there's the prompt optimizer.
And that's in preview.
Which is in preview now. So features are evolving very, very fast.
Yes. Any other questions? All right.
Okay.
Thank you very much.
Thank you.